Welcome everybody to another Jackson Systems training webinar here in Indianapolis, Indiana. My name is James Yarnell. I'm one of the account managers here. And with me tonight is Mr. Mark Jones, rep from UEi Test Instruments. He's here to talk to us about a couple of their products. How long have you been with where you are now?
Well, we've represented UEi for about 10 years. So
10 years, that's a long time. And where do you live now?
So I live just west of Indianapolis.
So
yep, close by. And another thing close to Indianapolis is UEi is actually their shipping, calibration, certification, so forth is here in Indianapolis.
Okay.
So real close for you.
UEi's been around a while, right?
Yes, they have. In fact, they just celebrated 50 years.
50 years.
Of business in the U.S. So.
Wow, awesome. Well, look, I'll let you get to it. Those of you online, don't forget you can type in your questions, and I'll read them off to Mark for you, and I'll let you have it. Thank you,
sir.
All
right, very good. Thank you very much. So, all right. Well, thanks for those that came out here tonight too, as well. So, as well as join us online. So, most of you that deal with Jackson Systems are dealing with a lot of zoning. Which is airflow and things of that nature. So the instruments we're going to talk about tonight are our digital manometer and our anemometer. So and really going to work on where those are applied, where they're used in the system. So give you a little bit of information about the instruments to get started here. The EM201B, our digital manometer, that is a dual in port. So you've got a positive and a negative port. It'll read plus or minus 60 inches of water column. Your scales that it will read are inches of water, millibar, PSI, and pascals. It's got a dynamic min-max value capture as well as a data hold, and it does have a backlit display. So, a lot of times if you're in a basement or someplace else, inevitably the light is behind you. So you can hit that button there, you can see the backlit display light up so you can easily read it. This does have a rubber boot on it. And it's got a magnet on the back as well, which makes it convenient that you can put it on the side of the ductwork or in the furnace or air handler that you're working with, so you don't have to try and hand hold it and do what else you're doing. It does have an auto power off feature to save the battery, and it's got a 3-year warranty. So what all comes in the kit when you purchase the EM201SP kit? So this is available just as a manometer, but gets a lot more useful when you buy the kit that comes with some extra tubing. We've got barb fittings to be able to check for our gas pressure. We've got stepped T's that we can use for checking pressure switches, which we'll talk about a little bit later on. And as well, external static pressure probes. And we'll talk about the application of these and why these are important for some of your readings. So when you think of a digital manometer, a lot of times the first thing that comes to mind is gas pressure, because anytime you install a fuel-fired appliance, you should check your gas pressure. A couple of different styles of gas valves in the market. The one that's been around for a long time, you've got a plug there that we're going to remove that plug. We're going to insert our brass barbed fitting that's going to screw in place of that so we can check that gas pressure. But some of the newer valves don't have a removable plug. Instead, they've got just an Allen screw here that we're going to loosen that doesn't have to come all the way out in order to check our gas pressure. So you just loosen that up a few turns so that some of the gas can escape. Now the tubing that is included with the manometer generally isn't large enough to fit over that stub. And I picked this trick up from one of our customers, a contractor, but this is just some 3/8 poly tubing, and if you're careful, you can slip that over the tubing that's included, and now that will fit over your pressure tap on this style of valve that just has the little spud that sticks up here rather than the plug that you're going to remove to check your gas pressure. One thing to remember is too, a lot of gas valves have both a pressure tap for the inlet and for the outlet or manifold pressure. So you can check, this particular gas valve is a 2-stage unit. So if you need to adjust your gas pressure for the low fire versus the high fire, that's where you'd want to check that outlet or the manifold pressure so we know what that's operating at on your high and low fire rating. Then moving on to, one other thing I should mention here too. Anytime that we're checking gas pressure, we want to do that when the equipment is operating. Okay, we don't want to have the equipment off and check our pressure. We want to make sure and fire that appliance. And if there's other equipment, other parts of the building on that same gas line, that should be on also. Great example of that, had a customer with one of our equipment lines that we represent, said, man, these heaters are firing, but we're just not getting much output from them. Stopped by, the technician assumed that, hey, the appliance was lighting when running. He figured, hey, everything was operating okay. Well, when the equipment was off, we put a manometer on it. He had 11 inches of propane gas pressure. When the equipment started up, pressure dropped to less than 3 inches. So somebody had replaced the gas regulator, and rather than getting the appropriate sized one, they just used what they had on the truck. So he had a regulator that had about 50,000 BTU capacity and two 100,000 BTU heaters on that gas line. So what was happening was, as soon as the equipment came on, the gas regulator couldn't supply enough gas volume, which of course dropped the pressure. So anytime you're doing gas pressure, make sure the equipment's operating so that we're not having an issue with insufficient supply. Okay? Any questions at all on gas pressure before we move on to some of the other things that we can do with our manometer?
No.
Okay. All right. Okay. The other thing that we can do with our manometer is we can measure draft. Okay. So typically that draft is taken in our flue pipe. One thing to remember, equipment that's rated as category 1, so that would be equipment that vents with B vent, vent material, is going to have a negative pressure in the vent system, even if it's got a draft inducer. A lot of techs may see that draft inducer and say, hey, I got a fan that's blowing that exhaust out. It's not really blowing the exhaust out, it's fan assisting the draft through the appliance. So if you've got a piece of equipment that's vented with B vent, when you check the draft, it still should be negative pressure. Okay? That can be important because if we don't have enough draft to get rid of our products of combustion, that can lead to combustion issues. Because if I can't get rid of what's burning in my heat exchanger, okay, I'm not going to get enough fresh air across my burner. So if I have poor draft in a piece of equipment, I'm probably going to have high CO production. Okay? And there's several reasons that could be. Maybe we've got, a bird's nest, that's in our vent cap. Maybe we've got a draft inducer that, maybe it's an older one with the metal blower wheel and that wheel's rusting and coming apart, for some reason. Maybe the motor's starting to hang up, and get dirty or what have you. So there can be several reasons we need to figure out why do we have poor draft in that piece of equipment. If it's an older piece of equipment that's going into a masonry chimney, maybe some of the material between the brick is starting to corrode and we're leaking. Or a clean out. I've seen clean out covers that aren't sealing tight. As soon as you hold and press that over, all of a sudden your draft goes up. So you need to investigate that and find out what the issue is. But if you don't measure it, you don't know what it is. Okay? I don't know if anyone still works on oil equipment, but if you work on any oil furnaces, then we've got two places that we need to check for draft. One is in the flue, and that's what we're going to do when we set our barometric damper so that we've got the proper draft in the flue. And then we also have to check what they call overfire. So typically on oil-fired equipment, there is some type of an inspection door that's on that. Sometimes there's a threaded plug that you can remove to check pressure. Sometimes we have to drill a hole if somebody hasn't checked it before, but we want to check that overfire. One thing that can tell us if we've got a plugged heat exchanger is if we've got a high loss over that. So if we've got a high draft in our flue, but we don't have in our combustion chamber overfire, then we may have a plugged heat exchanger because that flue gas is not able to get out. Okay? So we need in all the oil equipment that's going to have that specification on what that pressure should be, both in the flue and overfire. Okay? Also, for checking pressure switches. Your newer equipment, we talked about ensuring we had the proper draft of our equipment. Our newer equipment has got pressure switches in it. That's where our T's come into place. So now we can put these T's in line with our dual input pressure switch to tell whether or not that we've got a pressure switch it's making. Sometimes you may condemn the pressure switch. If you go out to the location and you say, I got a bad pressure switch because it's not making. Well, maybe it's the switch is bad. Maybe it's a case of the pressure is not getting to the point where the switch contacts are going to make to be able to close. So with a digital manometer, you're actually able to check that and confirm which it is, and not go out, put a pressure switch on it, and find out that wasn't the issue. It wasn't the part, but we had a problem with our vent system rather than just the switch. Okay. Any questions on looking at draft on our various appliances or checking our pressure switches? Okay. All right. Let's move on to static pressure then. Okay. Anytime we want to check external static pressure in a piece of equipment, it's important that we use static pressure tips. And the reason being, if you look at these, I know it's probably not going to show up real well on the picture, but when you have these, you'll notice that there are small holes in both sides of those tips. And the reason for that is that eliminates the velocity pressure from that. If I were to take this manometer, put the hose on it, and then blow in the end of the hose, I could actually change that just because I'm blowing in the end of the hose. The velocity of that air is going to add pressure to that manometer, so it's going to add a reading. But when I'm checking static pressure, I don't want to include the velocity of the airflow. I want to know how much pressure that duct is seeing. That basically is telling us, when we measure external static pressure, how much pressure that the fan has to work against, whether it's drawing through the supply or pushing through drawing through the return or pushing through the supply. Those two combined give us our total external static pressure. Typically that's measured in inches of water column is what we read that in. And we use these static pressure tips. One other thing to point out too, they've got a magnet on the back of them. So when we drill that small hole in our duct, we can put that up and it's going to stay in place with that magnet. Now, depending on the type of equipment we're working on is going to depend on where we want to place those probes in the system to get an accurate reading. A quick and easy way to remember this is you want to measure the equipment for external static pressure as it was shipped. So in this first picture here, we have an air handler. Typically our air handler has the coil built into the unit. So when we get that air handler, you've got the blower section and you've got the A coil is in the air handler. So when the manufacturer has tested that piece of equipment and rated its CFM airflow with the external static pressure, it's done with that A coil in place. So we're going to put one of our static pressure tips here at the return at the inlet of the air handler. If we've got a filter on the system here, we want to put it in between the filter and the air handler because we don't want that filter to be part of our equation when we're looking with these tips. The other tip is going to go at the outlet of our air handler. So now we're measuring what that equipment is seeing as it was shipped and tested at the manufacturer. If we put these on the supply and the return, and we put the one in the return on the negative side of our dual input manometer, and on the one the supply on the positive side, then our math is done for us. Okay? We don't have to do anything. All we do is we're going to read our number, and it's going to give us the information. If we had a single input manometer, then we're going to take our reading on our supply, write it down. We're going to take our reading on our return, write that down, and we're going to ignore our plus and minus and just add the total. So we want the total number is going to give us the total external static pressure of that system. Okay? In this case, we're looking at our placement for a standard gas furnace, or it could be an oil piece of equipment. In that case, the gas furnace, our coil's not included. Yes, we've got a question.
Yeah, Roger asks, can you use the EM201 for whole house pressure?
For whole house pressure, it does go to pascals. So, and that's one reason, if you've got one of our older EM201s, it did not read in pascals. which is a finer measurement and typically what they want for reading house pressure. If you want the 201B, as in Baker at the end, that reads in pascals. So that does give you enough differential there to find out if you've got a leaky duct system, which typically if you're wanting to measure, you're going to measure inside the house and measure outside to see if when our blower comes on, how are we losing, if we've got a leaky duct system, that's going to show our negative pressure. So that's one reason we actually upgraded that instrument. So that's a great question. Thanks. Okay. All right, so on our gas furnace here, we can see in this case, we were going to put one tip between our return air filter and our return side on our furnace. And then the other tip is going to go in between the furnace and our supply air coil, our air conditioning coil, because gas equipment typically does not ship with the A coil in the equipment. That's a separate piece. So we want to test it as that manufacturer designed and set up that piece of equipment. Okay? Okay. And as I mentioned earlier, the EM201B has both a negative and a positive port. So we're going to connect that tip in the return duct to the negative port and the tip in the supply duct to the positive port. That gives us a direct reading of external static pressure, so we don't have to do that math. Okay? If we've got that single port manometer, take the readings separately, disregard the plus and the minus, and just add that total, and that's going to give you your external static pressure. Okay? So let's take a look at a couple of examples. How can we use that in a real situation if we're looking at? Okay? Typically your equipment that you're using, installing, in this case I used a Thermopride, their new 95% gas furnace as an example. This is our CLQS1. It's got an ECM constant torque motor. So this chart shows us at which speed tap, at what external static pressure the CFM, that piece of equipment, is moving. So in this case, let's take a look at the 75,000 BTU furnace with a 1/2 inch of external static pressure. On medium speed is going to move 1,513 CFM of air through that duct system. Okay? Now, if we had just changed that out, and I should mention as well, this has the ECM constant torque motor coming next year in 2019. That's a requirement. All your equipment you're going to start seeing with ECM motors on it. So this is something to pay attention to, because if I go out on an older piece of equipment, this is one I just happened to pull up as an example, at that same 1/2 inch static pressure on medium speed, this PSC motor moves less than 1,400 CFM of air, the same external static pressure. So I've got a 75,000 BTU furnace in both cases. This case, it has what they referred to as a 4-ton blower, because it can do up to 1,600 CFM. Kind of a rule of thumb is 400 CFM per ton. If we pull that out and put in this new furnace that moves 1,500 CFM, that's a difference of 170 CFM. So we may have a situation that, hey, that duct system can be a little noisy now because we're moving more airflow through that duct. So that's something that we can use to determine. We can look at the old piece of equipment, do an external static pressure test on it, find out what the CFM it's moving, find out what the new one's going to move, and maybe we look at our chart and we say, hey, I need to select a different pressure tap, or speed tap rather. If I go to medium low, now I'm at 1,300 CFM versus 1,500. So that may solve an issue. So anytime you're troubleshooting, trying to figure out an airflow issue, whether it be noise, balancing the system, to test that, know what your pressure is going to give you a direction to go to look for your solution. Okay. Okay. The other thing that this can tell us, if we have external static pressure and we look at our airflow, it can also give us what our temperature rise is expected. In this particular case, 1/2 inch of static pressure on that medium-low speed, we'd be expecting a 74-degree temperature rise across it. So that gives us an idea to troubleshoot and go in and find out if I've got an 80-degree rise instead of 74, I need to look for something. What else is going on in that system, because I'm not seeing what I would expect. Okay? And being in the industry, You know, friends ask me, hey, what equipment do you recommend? You know, the question is always answered with, hey, the installer is really more important than the brand of the equipment, because you can take a good piece of equipment, put it in wrong, it's not going to last very long. You can take a lower quality piece of equipment, install it properly within its design parameters, and you're going to get decent life out of it, okay? And this is one way that you can differentiate yourself from some of the other contractors out there that are maybe taking shortcuts and just going in and saying, hey, I got this, oh, it's same size, we'll pull that one out, put this one in, it's cheap, but you know what, maybe it doesn't work the way they expect it to, or that, you know, doesn't perform. So you go in and establish yourself as a problem solver. Word of mouth is a great thing, great reputation, good reputation, okay? So we take that example and we find that, hey, I've got too high of a temperature rise, I don't have enough airflow, how can I figure out where my issue is at? Okay? Well, a while ago when we were checking our total external static pressure, we wanted to eliminate, you know, the filter and the coil from that. Okay? Well, now when we're trying to solve our issue, let's take a look at what our pressure drop is across our filter. Okay? We want to look at the two different sides. So let's say I've got 0.11 on one side of this and 0.21 on the other. I'm going to subtract that and come up with 1/10 of an inch pressure drop across my filter, okay? Which is typically we would want to see 1/10 of an inch or less pressure drop across that filter. If I find out that, man, I've got 2/10 of an inch drop across that air filter, I need to figure out, okay, do I need to add another return somewhere else in the house to draw air from? Maybe I need to put, maybe they've got just a 1 inch and they go down into the big box store and buy that electrostatic filter that's got a tremendous amount of drop through it because they got allergies. Hey, maybe that's an opportunity to sell, hey, let's get you a 4-inch pleated filter in here that gives us enough surface area that now we can provide good filtration, okay, but yet we have enough airflow to solve the issue that we had with the piece of equipment. We can get our proper temperature rise across the heat exchanger, it's going to last, we're going to have a quiet system that operates as it's designed to operate. Okay. Let's say if our air filter was proper, we had the proper air drop. Well, let's look at our coil then. Okay. In this case, we're going to look at our inlet to our coil and our outlet of our coil, and we're going to take the difference between those two readings. Okay. The manufacturer specifications are going to tell you what the drop should be across that coil. If I've got a higher drop across that coil than I would expect to find based on the manufacturer sheet, I've probably got a dirty coil that's in there. I need to clean that so I can get a proper airflow across it. Okay? Okay. Any questions on taking our external static pressure across our different components of our system to find an issue? Okay? All right. Well, the last thing we want to look at as far as external static pressure, of course, is for zone systems. If you're working on a zone system that has a barometric damper in it, being able to test that so we can adjust and set that damper is a valuable tool. Yep, got another question.
Yeah, question here. Mike asks, how many scale settings does the EM201 have?
Okay, we've got 4 different, as far as our readings, what we can take, or as far as a scale of how many, what it will read to, it reads out to thousands, 3 digits is what it reads to. If that's what he's thinking of a scale as far as like a multimeter, what scale do you set on for voltage, it reads out to 3 points, so thousands. So, and if he's talking about scale as far as which readings, then we've got, the pascals, inches of water column, PSI, so forth.
That's good.
Okay. Okay. Very good question. Okay. And I will mention too, the EM201 reads out to thousands. We do have a 152, which is also a dual input. It only reads to hundreds. So that's a question we get sometimes is, hey, what's the difference between the two of those? One reads to hundreds, one reads to thousands. So, okay, very good. Thanks for the question. Okay, all right. Any others on that? Okay, but like I say, on the dampers, if you need to set that for air balancing, being able to measure that static pressure so you can make that adjustment, make it to the proper setting if you've got a bypass damper in that system. Okay? All right. Well, let's move on then to our DAFM4. This is our digital airflow meter. Okay. Some nice features of this unit are the fact that the anemometer reads from anywhere from 99 to 3,937 feet per second. Temperatures from -4 to 140 degrees Fahrenheit. Relative humidity from 0.1% up to 99%. So those are the readings that it actually takes. Then the other things we can calculate. So we can calculate our dew point, our wet bulb temperature, and we can also calculate airflow volume if we put in our area that we're measuring, whether that be a round duct or whether it be rectangle by putting our length and width in. Okay? So some of the uses there, surface or induct measurements, so we can go over to a supply air or a return air grill, so read what's coming out of the surface of that, or we can, and we'll walk through this later on, we can do an induct measurement by drilling some access holes in there. The nice thing is, as you can see, this is a pretty small head on this anemometer, so you only need a 3/4 inch opening in that duct to drill in there to be able to insert this into the duct. It extends out to up to 39 inches in length, so we can get across a pretty good sized duct to take that reading to get our good average. The advantage of the vane style is they are more rugged than the hot wire instrument. So for that, and being rugged is a good thing in the back of a service truck to have with your tools. Okay, and we can figure that it'll figure velocity as well. Okay, so in a little bit, okay, at the end here we've got a video that's going to walk through how to enter that because it spells it out in the manual. I could go through that, but I know that's probably not something you're going to remember going through this to take the steps and what we're actually going to hit. Got a video at the end of that that shows that, that's actually available on UEi's website as well, so we'll do that here at the end. But to measure air duct volume, if we just want to do a quick volume sample and simply estimate it, we can put this in volume mode, put it in front of a register or in a duct, and get a real quick reading that's going to give an estimate. But as we all know, the size of a duct, it's not going to flow the exact same amount of air all the way across that duct. You've got a little bit different air movement out by the edges versus in the center. So the best way to do that, to get the most accurate reading, is a time average measurement. Okay, so this allows us to do this because we've actually got a start and stop button on here that we can hit start for the timer to run, it'll take a reading, then we can hit stop. We can move over to our next opening and do that. Just real quick to walk through that, how we're going to do that. We enter the volume mode, then we're going to enter the length and width or the diameter if it's a round duct, and if we're looking at a grill, we're going to adjust that area for the free area space. Whether it's a 75%, which is pretty common open free area for a metal duct, or maybe a 40 or 50, if it's a wooden decorative duct, or rather grill. Okay. So once we go into the mode, we're going to select either length and width or area. We're going to use our up and down buttons to enter that, get us a square cross section of what the area is of that ductwork. And then we're going to press our stop button so that we've got that ready. Okay. Depending on the size of our duct is going to dictate how many openings we need to get a good average measurement. If it's 18 inches or less, 2 holes, 6 inches apart. 18 to 35 holes, 30 to 36, 6, or greater than 36, 7 access holes to get in to get a good average of that duct. Okay. And this gives us our dimensions on the relative to the inner wall versus the outer wall of making a cross, so we know where to put our holes in our duct so we can get an accurate measurement. So what does that look like? Basically, here's the math. If we were going to use an example of a 20-inch inside diameter opening with 5 access holes, we're going to take the 20 times a 0.074. So our first opening is going to be 1.5 inches over from the wall of the duct. Our second one, 20 times our 0.288, which gives us just about 5 3/4 inches. Then we're going to be over at 10 inches, 14.5, or 14.25, and 18.5. So what that allows us, got a diagram here, is this gives us a good section to measure an airflow across that entire duct. When we put this in that first opening, we're going to hit the button to start, and we're going to want to slowly go across from one side of that duct to the other. We want to make sure that our vane is pointing the proper direction, with our airflow, not at a 90 degree, okay? So that we're getting good airflow, getting an accurate measurement. We're going to hit stop when we get to the other side. Pull it out, go into our next opening, hit start again, slowly go across that duct, hit stop, go into our next opening, okay, until we're done. Then that's going to average that reading that we've taken and give us a time average of what that entire duct is flowing. Okay? And when we're doing that in a round duct, we're going to want 3 openings. We've got one here in the middle, come down 60 degrees, do another one, up 60 degrees, so that way we can go all the way across and we're getting a good cross section again, so we can see an average of what's moving over that entire duct. Okay. And like we mentioned earlier, as far as the effective area of a grill, okay, we're going to do our calculation. Yes.
Question, yeah. Mike asks, and maybe you're about to get to this, so forgive me if it's premature here. Can the DAFM4 calculate round and rectangular duct? So I don't know if maybe it's a setting you put in the instrument or not.
Yep. Yes, it could. Yeah, we can do round or rectangular. When we walk through, when we're pressing our length and width or diameter, there's 2 settings rather. You've got length and width. So if you've got a rectangular duct, you're going to select how wide it is and how deep it is. And then if it's a round duct, we're going to enter diameter for that instead of the rectangular. So, yep, do both. Okay? All right. So then for our grills, okay, what we're going to do is we're going to figure up our square inches to get that, convert that to feet, and then we're going to multiply that by either our 0.7, which is pretty common for a metal grill, or some wooden decorative grills can be as low as a 0.4. So they've only got 40% free airspace. So hopefully you've got the you can identify that grill and recognize it and kind of look at the manufacturer specs to see what its free area space is to give you the most accurate reading for that adjustment. Okay? Okay. So if we had a 4x10 residential floor register, 4 times 10, 40 square inches, 40 divided by 144, to convert that to square feet, that gives us what the area is we want to enter when we're calculating that for a grill. Okay. Okay. And that's coming up here. I thought we had one more. Now we're going to go through our video real quick here, unless we've got any other questions on taking that measurement. This is just a short video, about 3-4 minutes long, that kind of walks through what we were talking about doing from one of our fellows at Engineering and UEI here. So, okay.
Hi, my name's Dave with UEI. Today I'll be conducting an introduction to the Induct DAFM4 vane anemometer. This tool comes packaged in a hard carrying case and includes the handset and then a small vane anemometer that extends to 39 inches. Measurements include air velocity, temperature, and relative humidity, and from those it can calculate dew point and wet bulb, as well as air volume in CMM or CFM. The base also allows you to do a timed average up to 99 minutes to get a good average over the surface or in a duct. Some of the benefits that an induct vane anemometer has over other technologies is it's more accurate than hot wire and more rugged. The key to this, though, is it combines relative humidity with the velocity and temperature, giving you all the measurements in one tool. Next, we'll be preparing the site where the measurements will be taken, drill some access holes, and then go to work with the DAFM4. This is a 20-inch duct, and if you look on page 8 of the user guide, you'll see we recommend 5 holes, and it gives you the spacing. I've already calculated it out, so I'm at basically 1.5 inches, 5 3/4, 10, 14 1/4, and 18 1/2. These are my spaces. I'll go ahead and drill those access holes, and we'll begin taking measurements. So the first thing before we use it is I want to set the units to inches instead of metric. So I'm going to press and hold the on-off until the units option, and then I hit enter, and then you can either do up or down to change between Fahrenheit and centigrade, or standard and then metric. So I'll put it in degrees Fahrenheit, then I hit enter, and then exit takes you to normal mode. In normal mode you have velocity, and you just scroll through by pressing mode, volume, I'll come back to that, ambient temperature, relative humidity, white bulb temperature, and dew point. So I go back velocity, and that's just direct read. So you'll see that reads. Go into volume, and you'll notice down in the corner it has a LW. You either do length, width, diameter, or area. So I'm going to pick length, width, and hit enter. We're 16 by 20, so on the length or width, I'll start out and do 16. 16, hit enter, and then 20, and hit enter. Now I'm measuring volume based on a length and width of 16 by 20. And I'll take you through and do a timed average next. We've now got the DAFM4 setup for 16 by 20. I have my access holes drilled into the ductwork, and I'm going to begin a timed average. So first you make sure that the vane is extended long enough to cover the depth. And then you check there's an air in on one side, that's the direction of the airflow. And I'll put that right on the inside of the ductwork, and then I hit start and slowly traverse that access hole until I reach the other side, and then I hit stop. I go to the next access hole, I hit start, and I very slowly go across that until I hit the far side, I hit stop. And you'll notice the handle is elongated so you can keep the direction proper. After I have all the measurements taken, my total time is 36 seconds. If I hit min-max average, I have 1379 CFM. I can do minimum 87.5, maximum 2360, so that tells you the span throughout the duct. Back to that. To repeat it, I just press and hold exit. It'll clear that. I still have the same length and width. Start again. So now I'm going to do a demonstration on a grill surface area. And you'll want to get the AK, or the effective area, from the manufacturer. And I've got this one, it's 1.5. I only go down to about here. So I'll again go to volume, and then length, width, diameter, area. I got length, width, D for diameter, A for area, it's program 50. Hit accept, and then you would change that. I already had it 1.5. And then hit enter, and now I'm measuring volume. Again, air in, so I got the direction of the airflow, and I hit start. You basically paint the surface of the grill. Done, you hit stop. The average, 1120, 1150. I'm within 30 CFM, so we have a 3-ton system. It's about 400 CFM per ton, so good with the setting for the airflow in the system. That's the DAFM4 small vane induct anemometer from UEi. Thanks for watching.
So we can see there, you can see just once you do that a few times, read through the manual, enter in that duct information so you can take those measurements. That's handy. You could go around to every grill in the house, and then you could find out how much your duct system was leaking if you figure out, hey, I've got so many CFM at the furnace, and I'm so many CFM at my registers. That give you the total. You can see how much your duct system's losing. So, great handy tool. Again, all those are for diagnosing, installation, making sure that system is put in properly, however you want to balance the system. A lot of different options. Okay. Thing I'll leave you with is some contact information for UEi. If you need any service, questions, things of that nature, of course, you've got your contacts here at Jackson Systems as well. We kind of mentioned a little bit at the beginning. UEi ships out of Indianapolis, which is where Jackson's at. So if there's anything they don't have, we can get a quick turnaround for you and get it out the door. So, all right.
All right. Well, there's a lot of great information there. Thank you so much for coming in. Hopefully we'll have you back real soon. And folks, thanks online for all the questions. Appreciate that. And that's it for tonight. Don't forget, if you want to try any of these instruments out or have any more questions, you can call them or you can call us at Jackson Systems. You can also go to jacksonsystems.com, and we'll have this video and all the other webinars that we've done in the past. We'll have it on there where you can watch it whenever you like on demand. So maybe you missed something tonight, you want to go back and watch it again. Maybe you logged in late and missed something at the beginning. It'll be there for you. So again, thanks to you from all of us here at Jackson Systems. I'm James Yarnell. We'll see you next time.